Okay, guys, so this is basically the hypothesis testing. That's the part that you might be a little bit confused a little bit. If that's the case, I'm gonna go over. So hypothesis testing basically means this. Researchers are interested in answering many questions or many type of questions, such as, is the earth warming up? Does the new medication lower blood pressure? Does the public prefer a certain color in a new fashion line? Is a new teaching style or technique better than the traditional one? Do seat belts reduce the severity of injuries? These types of questions can be addressed through statistical hypothesis testing, which is a decision-making process for evaluating claims about a population, right? So this is basically it, right? It's basically we're trying to test whether or not our claims are can change the status quo of whatever it's being for, let's say, many years or so, right? So there's three kinds of hypothesis methods that we use: the traditional method, the p-value method, and the confidence interval method. Steps in the hypothesis testing: the traditional method. Hypothesis testing or a statistical hypothesis is a conjecture about a population parameter. This conjecture may or may not be true. Yes, sometimes the null is not true, right? Or the alternative, we said we reject or we fail to reject, right? The null hypothesis symbolized by HO is a statistical hypothesis that states that there's no difference between a parameter and a specific value, or that there is no difference between two parameters. So if the null is true, then meaning that the difference might be due to chance, right? And the alternative hypothesis symbolized by H sub 1 or H sub A symbolized that is a statistical hypothesis that states that the existence of a difference between a parameter and a specific value, or states that there is a difference between two parameters, right? So sometimes if we might encounter statistically significance, then that means that that's not due to chance. So there's an actual difference between the values, right? And I told you in the class that you should remember this, right? So if you confuse either which one you should do, remember that the null is always equal, less or equal, or greater than equal, and this parameter can change, right? It can be the mean, variance, or whatever. But for this situation, I'm just reminding you that this is the mean, the actual parameter, right? So this can change, right? But just remember the signs. This is what I want you to remember, okay? So if you're confused whether the claim should be in the null or in the hypothesis and the alternative, then you remember this little rule, right? So just make sure that you remember that. Okay, so let's go straight to a problem. Here they said, medical research is interested in finding out whether a new medication will have any undesirable side effects. The research is particularly concerned with the pulse rate of patients who take the medication. Will the pulse rate increase, decrease, or remain unchanged after a patient takes the medication? The researcher knows that the mean pulse rate for the population under study is 82 beats per minute. So he wants to find out if it's increasing, decreasing, or remain unchanged. So that means that the alternative hypothesis, it should be a two-tailed test, right? How do I know it's a two-tailed? Because they're saying increase, decrease, or remain the same. So it's either the mean pulse rate is 82, that would be the null, so there's no difference, or there's a difference, right? There's a difference. So they're supposed to be not equal to 82, right? Remember, in the null, it's always equal, right? So it should be, and the claim is this one, right? We're trying to find out if the medication decrease or increase the pulse rate, right? So that's the claim, that's it. And this is a two-tailed test, like I explained before. This part. A chemist invests an additive to increase the life of an automobile battery. Okay, increase, this is the magic word, increase, right? So increase, that means that this is what? This is a right-tailed test, right? So he wants to find out if it increased. The mean life battery is 36 months, so he wants to find out if it increased. So the alternative, I'm sorry, the null should be less or equal than 36, and this is the claim, because he wants to find out if with this additive or this invention that he made, it will increase the lifetime of the battery, right? So that's what he needs to do. He wants to find out if his invention makes the the battery lasts longer, right? So that's what you need to do, okay? And again, this is a right tail test. The next situation you might encounter is a left tail test, right? So here they're asking you, a contractor wishes to lower heating bills. So you can tell right away, he wishes to lower. So lower means less than. So the mean, the average, right, is less than 78. He wants to lower it, so the alternative should be greater or equal than 78. So this is the claim, right? And he wants to lower it, so that's it. That's all you need to do. So sometimes they say when the claim, when a researcher conducts a study, he or she is generally looking for evidence to support a claim. Therefore, the claim should be stated as an alternative hypothesis or research hypothesis. A claim, though, can be stated as either null hypothesis or alternative hypothesis. However, the statistical evidence can only support the claim if it is in the alternative hypothesis. So don't forget that. Statistical evidence can be used to reject the claim if the claim is in the null. Okay, so that's what they're saying here. These facts are important when you are stating the conclusion of a statistical study, right? So we're always looking for statistical significance, right? That's our main goal. So after stating the hypothesis, the researcher's next step is to design the study. The researcher selects the correct statistical test, chooses an appropriate level of significance, and formulates a plan for conducting the study, right? So you can choose what test you want to use and what significance level you want to use, right? A statistical test uses the data obtained from a sample to make a decision about whether the null hypothesis should be rejected. The numerical value obtained from a statistical test is called a test value, right? It can be a C-test, a t-test, chi-square test, depending on what you're trying to reject or not reject, right? In the hypothesis testing the situation, there are 4 possible outcomes. So here you have, in reality, the null hypothesis may or may not be true, and a decision is made to reject or not to reject on the basis of the data obtained from a sample. So a type 1 error is reject when it's false. I'm sorry, reject when it's true. So this is a type 1 error, right? So sometimes they call this a false positive. I have that here. So, and then sometimes we have the type 2 error when we fail to reject when it's false, right? So the first one is reject when it's true, and the second one is fail to reject when it's false. So this is the type 1 error. This is called sometimes a false positive, and you have the type 2 error, which is a false negative. So sometimes we refer this as 2 alpha, right? The type 1 error, and the type 2 error as beta, right? So make sure that you understand these things. Okay? So here you have a hypothesis testing. Reject when it's false, right? I'm sorry, reject when it's true is a type 1 error, and fail to reject when it's false is a type 2 error, right? Again, this is referred as beta and alpha. Type 1 error is alpha, type 2 error is beta. Remember, this is what? This is a false positive, okay? And this is a false negative, okay? So like they say here, reject when it's true, that's a type 1 error. Fail to reject when it's false is a type 2 error, right? So the level of significance is the maximum probability of committing a type 1 error, right? So if the level of significance is 0.05 and we reject a true null hypothesis, right? We're committing a type 1 error, right? Rejecting a true null hypothesis as a type 1 error. So the probability of making a type 1 error is 0.05 in here, right? Likewise, if you fail to reject when it's false, then you're committing a type 2 error. So that's also known as beta, right? Okay, I hope this makes sense. So hypothesis testing, you have significant levels range from 0.10, 0.05, and 0.01. Those are typical, or like in most cases, you will see this often. You might see this in psychology, and you might see this in labs or pharmaceutical studies, right? For example, when alpha is 0.10, there's a 10% chance of rejecting a true null hypothesis or a type 1 error, right? Just remember that alpha is type 1 error, right? And it's a false positive. Okay, so hypothesis testing, the critical value, CV separates the critical region from the non-critical region. So remember when you have your distribution, right? Your, let's say this is a C-test, this is the critical value, right? So whatever that is, like let's say it's 2.33, let's say, right? And it's a right tail test, let's say. It's an example, right? So that's the critical value. The rejection region, it's in this area right here. So if anything falls within that area, that means that you will have to reject the null hypothesis, right? And if something fails here within this region, then you will say that's the non-critical region or the non-rejection region, and you will fail to reject the null hypothesis, right? So that difference might be due to chance, right? Okay. Okay. So here they want you to find what they want you to find the critical value with alpha, the significance level 0.01. So if it's a right tail test, you will do 1 minus alpha, which is 1 minus 0.01. So that's 0.99. So you need to look at this probability on the Z table, on the standard normal distribution, and say what is the value for that, or what is the C value for that, right? So if you look at the table, you get this value, right? I mean 2.33. Let's see if that's true. So we look at the table. It was 0.99. So we need to look for that probability, 0.99. That's about here somewhere. So that's here. You can see. So this is 2.33, right? You can see that from here, 2.33. So that's what they're telling you here. So this is 2.33. So that's what you need to look for. So the C value is 2.33. So if they are asking you for that left tail, you will just do one. I mean, you just look for the probability of 0.01 in the standard normal distribution. So you look for C here, 0.01, and you just look for that. Let's look for that 0.01. What is that? 0.01, 0.01. Let's see, what is that? 0.01. So this is about negative 2.32 or negative 2.33, right? And notice that due to the symmetry, if I find 2.33 to the right, I should find 2.33 or negative 2.33 to the left, right? Okay, due to symmetry. Okay, so if you find this one, you just can look at the other, right? And if it's a two-tail test, you should remember those numbers like I told you in class before, right? This is 1 minus alpha over 2, which is 1 minus 0.01 divided by 2, which is 1 minus 0.05, right? And you should get 0.995, right? If you're looking for this part, right? But you should know by now that this is 2.58 because this is a two-tail test, so you should remember that, right? The same thing when we were doing the confidence intervals, you should remember that value. So if you want to look at the table because you forgot or you never remember those values, you go here and you look for 0.995. So let's see what is 0.995. 0.995 is here. So this is 0.995. So it's about 2.5, and I think it's 8 here. So you can see clearly that it's 2.58, right? And if you don't know, this is 2.5. And then this guy is 0.08. So you should add it up and you get 2.58. That makes sense, right? Hopefully it makes sense to you. Okay, so that's how you find that stuff. So here they're giving you a procedure, right? That's the same thing I just explained to you right now. If you're looking for a right tail test, right, you just do, draw, right, your graph if you want. And for a left tail test, you just need to look at the alpha value. And for example, if it was 0.01, you need to look for that probability of 0.01, and you need to find what is the C value equals to, right? And if you're looking for the right tail test, you will have to do 1 minus alpha, which is 0.09. 99, right? So that you will need to look for this probability in the table. And if it's a two-tailed test and it's 0.01, let's say, you know that that's 99%. So that should be 2.58 here and negative 2.58 here, right? Because it's a two-tailed test. So you should know that by now, right? But you can also look at the table, right? Because it's 1 minus alpha over 2, 1 minus 0.01 divided by 2, you know what that is, right? I think you understand that. Okay, let's continue. So here they want you to find a left tail test. So you do the same thing, right? If you want to find out really quick, left tail test, it would be 0.10. So that means a left tail test, I just need to look for the C value that corresponds to that probability. So 0.10, that will be here, right? 0.10, 0.10, that should be here somewhere. 0.10, let's see, 0.10. 0.10, I think is this one, right? This is 0.10. So that's negative 1.28. Yes, 81.28. You can see that from here. 1.28. So negative 1.28, negative 1.28. So that corresponds to that, right? If you're looking for a two-tailed test for 0.02, right? You should know that that's 98%. So this is 2.33 and negative 2.33. I told you to remember these numbers. So that's what you get, right? But if you don't remember those numbers, you will need to go on the table and do all that, right? So you will need to do, it's a two-tailed test, right? You will need to do, like they say here, right? Alpha over 2, right? And remember, it's, if you want to look for this one, right? It's just alpha divided by 2, right? And alpha is 0.02 divided by 2 is 0.01. So you need to look for that value, 0.01, right? So you look at the table, 0.01, and you find whatever the value is, right? 0.01. What is that? 0.01. 0.01 is around here. Let's see, what is it? 0.01. That's here, right? So that's negative 2.33, right? Or negative 2.32. So negative 2.33 and 2.33, because due to the symmetry, remember? Symmetry, they should be the same. Okay? So a right tail test. So if you do a right tail test, you will have to do this, right? So right tail test is 0.05. You need to do 1 minus alpha, 1 minus 0.005, whatever that is, right? So you can use your calculator and you can find out what that is, right? So that you will be 1 minus 0.005, and you get 1, right? At 1, I'm sorry. 1 minus 0.005. Okay, I can use my calculator. So this is whatever that is. Okay, so give me 1 second. Computer got frozen. Okay, so this is 1 minus 0.005, and you should get this thing, right? So 0.995. So if you look at that, you just need to look at your table, at your in your standard normal distribution, right? 0.995. So 0.995. So what is that? 0.995. 0.995. 0.995. So that's what is that? 0.995. Yeah. So that's negative 2.58, right? 2.58, because the maximum is 9. So this is 2.58. So this is 2.58. And that's to the right, so that you should get, right? Okay, so now we're going to talk about this procedure, right? The traditional method, you need to state your hypothesis, right? You need to find the critical value, compute the test value, make the decision to reject or not to reject, and summarize your results. This is very important, so make sure that you state it at the end, what this means, right? All these numbers and all this calculation. So the test for a mean right? So the C test for a statistical test for the mean of population can be used when n equals to 30 or the population is normally distributed and sigma is known, right? So that's why you need to remember. So here, the sample size is 30 and sigma, the population standard deviation is known, right? So you can use the C test in this situation. So let's do an example. I'm gonna do the example in another page. So after that, we don't need to look back and forth. So what is that? Let me do that here, okay? So this is what they're asking, these people, right? So a research reports that the average salary of an assistant professor is more than 42,000. A sample of 30, so n equals 30. Assistant professors has a mean salary, so that's the mean of that sample. So that the mean of that sample should be like this, right? 43,260. And at 0.05, right? There's a claim that the assistant professor earn more. There's a claim, so this is the claim. There's the claim that the assistant professor earn more than, so more than 42,000. And then the no should be he make less or equal than, these professors, they make less or equal than 42,000, right? So that's the your null and your alternative hypothesis. Obviously, this is the claim. How do I know that? Because here they said, there's the claim that the assistant professor earned more than 42,000. So it should be more than that, right? So this is the part, this is the claim. So now that you have the claim, now you need to use the C values, right? So the mean, the population mean is 42,000. And the standard deviation of the population, so that's sigma, right? It's 5,230. So what you need to do is very simple. You just need to do the C test, because we have all the conditions. The sample size is 30. What else they said here? They give us the population standard deviation. Okay, so we can assume normality, even though they don't mention here. But anyway, so this is x minus mu, sigma over square root of n. X is the mean is 43,260. This is the mean of the sample minus the mean of the population, which is 42,000. And then this is divided by sigma, which is 5,230 divided by the square root of n, which is just 30, right? And then we just compute these things. I'm gonna bring my calculator because I forgot. Okay, just give me 1 second. Okay, so you just need to subtract these values, right? 43,260 minus 42,000. And you divide this by, you do 5,200 divided by 30. And you get your answer, right? Whatever that is. So I get 1.31 or 1.32, let's say. Okay, so that's my C test, right? When you're doing the traditional method, you're comparing the C values basically, right? And now you need to compare that C value from your test or your C test with the significance level that they give you here. So they give you 0.05, right? So that's your significance level. Remember, this is greater than, so you have to remember that this is a right tail test because they say greater than, right? Or earn more than that. So you need to find the C value, right? At significance level 0.05. So because it's a right tail test, I have to do 1 minus alpha, right? Which is 1 minus 0.05, which is 0.95, right? Because it's just one tail test. So I need to look at this probability and find the C value that corresponds to this probability. Okay, so 0.95. Let's look at the table. 0.95. So let's look for that. Again, I know these things, but I'm just doing it for you to remember, okay? So so this is negative 1.65. You can see that clearly here. So 1.65. So that's my C value. So I need to compare this value with this value. Is this value in the rejection region or in the non-rejection region? So that's this 1.32, it's to the right, I'm sorry, to the left of the 1.65, right? That should be here somewhere, right? So that means that that falls in the non-rejection region. Therefore, you cannot fail the null hypothesis, right? So you will say what? You will say, you can state your conclusion now. You can say, there's not enough evidence, right, to support the claim that that the average salary of assistant professors is more than 42,000, right? Okay, that's what you need to say. So that's it. That's what you need to do. Okay. And remember, always, there's always a probability of making a type 1 error, right? Rejecting a true null hypothesis, right? Or fail to reject, right? Fail to reject when it's false, right? So that's the type 2 error. So you have to keep in mind these things all the time when you're doing these things, right? Okay, so that's it. So that's the answer. So we said fail to reject the null, right? Fail to reject. So that's our this is our conclusion, and this is what we're supposed to summarize at the end, right? So let's see what they did on the slide. Okay, basically the same thing I said, right? Okay, so that's how you do that. So here there is some important comments I said. Even though in example 8.3, the sample mean of 43,260 is higher than the hypothesis population mean, which is 42,000, it is not significantly higher. Hence, the difference may be due to chance, right? Because when we fail to reject, right, the null. So that means that difference, it might be due to some, maybe if we choose other people, the result will be different, right? When the null hypothesis is not rejected, there is still a probability of type 2 error. Rejecting, fail to reject, right, when it's false, right? And when the null hypothesis is not rejected, it cannot be accepted as true, right? Because we don't know. Even though we fail to reject, it might be the case that we might have that type 1 error, right? So you have to be careful with that, right? When you're making your comments or your summaries at the end of once you finish the problems, right? Okay, so let's continue. So here they give you, I'm gonna copy these values and I'm gonna take it to the other sheet so we can do it from scratch basically, right? So let's do this here. So here they said a researcher claims that the average cost of men athletic shoe is less than $80, right? So is less than. So you know what the claim is, that is less than. So the claim should be here, less than, right? So less than $80, that should be the claim. You know that that's your null. And then you, I'm sorry, the alternative. And the null should be greater or equal than 80, right? Okay, he selects a random sample of 36, so we can use the C test, right? And he said like he selects a random sample of 36 pairs of shoes from a catalog and finds the following cost in dollars. The costs have been rounded to the nearest dollar. So is there enough evidence to support the research claim So this is the significance level at 0.10. So assume that this sigma is 19.2, right? So this is the population standard deviation, right? So we need to use our calculator to find these things, right? So I'm gonna use the calculators and just review it with you how to type this in calculator to find whatever we're looking for, right? From this data. Let me see, give me 1 second. I have to look for that calculator, online calculator. Give me 1 second. 1 second. Okay. Okay. 1 second, guys. I'm looking for the calculator. Here it is. Okay, so let me share this with you. Where is that thing? Okay, I don't have that with me right now. By the way, you can skip this part when you watch this video. Okay, just skip this part. I'm just looking for that. Well, let's assume that I'm assuming that you know how to do that. Okay, so let's put that in the calculator, and I will give you. I will do that because I don't know what it is, that thing right now. So anyway, so if you put that in your calculator to find the values, right? Just make sure you go to your stats and then input the data, right? In the other video, I will look for that and I will record this for you. I promise you. Okay, in the other part of the video, what is that? Stats, edit. So you input this data. Oh my God, what's that? 60, 70, 75, 55, 80, 55. I have this information from the slide, so I'm just gonna go over to save time, okay? So I supposed to get, for my standard deviation, I have, what is my mean? The mean is 75 based on this, okay? So 75 is the mean. And I just need to calculate the values, right? So I do my C test equals X bar minus mu sigma square root of N. And I just need to compute this thing, right? So this is X bar, 75 minus the mean is 80. Sigma is 19.2, and the standard deviation of the, the sample size is 36. So that's -5, 19.2 6, right? And we just need to put this in the calculator. So if we do that, we get 19.2 divided by 6, -5 divided by that. I get negative 1.56, okay? And we need to compare this with the c-test, right? So we know that this is a left tail test. So what is the c-value for that? We have a significance level of 0.10. So remember, when we have the significance level 0.10, if it's a left tail test, we just put the c-value that corresponds to the probability of that. The probability of 0.10, we look at the table, and 0.10 is right here somewhere. Okay, 0.10 here. Here is 0.10, and that's an 81.28. So that's negative 1.28. So we compare this value that we have from the c-test with this value, and this value you can see that from the test that is more extreme than that, right? That's more to the left, and it falls into the rejection region, meaning what? That we have to reject the null hypothesis. Therefore, we can say our conclusion will be reject the null, right? Reject the null hypothesis. Therefore, we can say, therefore, there's enough evidence to support the claim. The claim that what is it? The average cost of men athletic shoes, at the average cost of men's athletic shoes is less than $80. Okay, so that's what you need to say. Okay, so this is your result and this is your conclusion, right? So that's what you need to do. Okay, so reject the null. So let's see what these people did. 81.56, and there's another evidence to support the claim that the average cost of same thing, right? So here we can do this right now. So let's write this here in the other sheet, and then after that we can practice these problems. Okay, so here you have here you have the medical rehab education foundation reports that the average cost of rehab for stroke victims is this value, right? So the mean is 24,672. To see if the average cost of rehab is different at a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and finds that the average cost of the rehab is 25,000, right? 25,226. So this is the mean of that sample, right? Standard deviation of the population is 3,251. Alpha is 0.01. And can we conclude that the average cost of rehab at a particular hospital is different? So you see how they say it's different? It's different, right? It's different means what? It's a two-tailed test, right? That's what they're asking. So you should say the null is that is equal to 24,000, right? $672. And the alternative should be that it's not equal, right? Could be more, less, or whatever. So 24,672. So now we have to see where we should put the claim, right? So you read one more time. The Medical Rehab Education Foundation reports that the average cost of the rehab for stroke victims is 24,000. To see if the average cost is different at a particular hospital, a researcher selects a random sample of 35 stroke victims at the hospital and finds that the average cost of the rehab is 25,226. The standard deviation of the population is this. Can it include that the average cost of stroke rehab at a particular hospital is different, right? So again, this is the claim, right? So that's what you should do. Now you know that this is a two-tailed test. So this is C equals X minus mu sigma square root of n. X equals 25,226 minus the mean, which is 24,672. The standard deviation is 3,251, n is 35, and this is calculator, right, from here. So 25,226 minus 24,672, and then you do this thing, divide by 35, and then you divide this by this thing, and you get some value, right? You get 1.008, or you can put 1.01. Now we need to this is a two-tailed test, right? So we can find the C. You can draw your, this is a two-tailed test. You need to find your C's, right? So we know that this is 0.01. So that means that this is going to be 1 minus alpha over 2, 1 minus 0.01 divided by 2. That's going to be 1 minus 0.005, right? But we don't need to do that because it's a two-tailed test, and we know what's the value of 99. So 99 is 2.58 to the left and 2.58 to the right. Therefore, this value is 1.01. So that's not it. This value is in the non-rejection region. So we fail to reject, right? So we can say fail to reject, right? Because this value right here, it's here somewhere, right? And this non-rejection region, right? Non-rejection area or region, or whatever you want to call it. Therefore, we said there's not enough evidence to support the claim, right? There's not enough evidence to support a claim. This is what you're supposed to do on the test. That the average cost of rehab for stroke victims is different than $24,672. That's it. That's what you need to say. Not difficult, right? I mean, it's pretty straightforward. Okay, so that's that part, right? So you can say these things, and then you can say, okay, there's not enough evidence to support the claim that the average cost is different. Okay. So now we're going to the other method, right? Because there was 3 methods, right? The traditional method, the p-value method, and the confidence interval method based on these slides, right? So the p-value or probability value is a probability of getting a sample statistic such as the mean or a more extreme sample statistics in the direction of the alternative hypothesis when the null hypothesis is true. I'm gonna stop here because this video is long already, and I'm gonna do part 2 and part 3. Once I'm done with these slides and all these examples, I'm gonna do the actual practice test, okay? Please practice this, okay? Because after that, when I give you something else and you don't understand what I'm doing right now, then you're gonna get confused, okay? I promise you I will do the practice test, I promise you, okay? Have a nice day.